good amount of time.
Yeah.
On Excel. So that I can do something. I plug in now sheet and then I go through it's just more organized. I don't and I felt pretty cool. One bead.
Is it really?
Whereas Mullins does.
What is our strawberry? Oh, I was saying. Sour straw the strawberries get this. Well, let's just shift their apples in them. Actually, you put that last. You're fine. Sure.
Morning. How's it going? Good. Survived the first week of class? Just the first week, right? Second week of class? I'm like, so it's weird, but not till March. Not till March. You had that Monday off. You had Monday off. Right? So look, I mean, it's crazy, right? I had class a week. So we're gonna get you back, and we'll go kind of slow. Get you back acclimated. So jumping right in, we're gonna have a top quit. No, I'm just kidding. What are we gonna do today? So big agenda for today. Questions from last week. Do you guys have any questions from what we did last week? Do you remember what we did last week?
The quiz was helpful.
The quiz was helpful. So the stuff we went over in class, the quiz was good. And you guys just had to finish the quiz. How many of you guys just finished it like right before class? Maybe. Remember, I can see when you turn stuff in, so I know who's going to do that for fun. No, you guys are great. You totally finished it by midnight last night. It was wonderful. But yeah, no, you guys have any questions from last week?
Yeah, there's a concept of cross-validation and stuff.
We'll talk more about that today, so that'll help a lot. Yeah. Any other questions?
Can you discuss the quiz? Help us to see we read understood.
Sure, we can discuss the quiz. I haven't graded the quiz yet, but sure, we can discuss it. Like what?
In the three scenarios which you gave.
For the supervised, unsupervised.
Like this looking easy. I think I can make that happen.
Good job. It's really close. Really?
Hold on, wait. Yes, you can go. So you guys were on concept quiz. So my Saturday class is a whole week ahead of you. So I'm like, I've already taught this, but I haven't, but I haven't, and so I'm just trying to make fresh everything. SSS, that is what's new. trying to figure out what the main difference is between supervised and unsupervised data mining.
If you have a target.
You got a target or not? Supervised has a target, unsupervised doesn't have a target. Hopefully that's what that says. Excellent. Okay. Let's see what we have for the next one. So deciding whether to issue a loan to an applicant based on demographic and financial data. Supervised or unsupervised?
There's a target here.
Okay. There is a target variable. Supervised, I mean the answer is there, but everybody's good with supervised?
So the target is whether to issue the loan or not?
Yes.
Okay.
Yeah. So I issue the loan or I don't issue the loan. So as far as the data mining category, task would be a supervised task. So it's either supervised or unsupervised, but supervised, and then you can go a step further and you can decide if it was estimation or classification. So in this case, what would it be? Classification, because we're trying to decide loan or no loan. Let's see if I can. In an online bookstore, making recommendations to customers concerning additional time to buy or additional items to buy based on the buying patterns in prior transactions.
What is additional items to buy today?
I'm hearing mostly unsupervised. Right? There's not a categorical variable we can pick. Buy this, don't buy this. Right? There's definitely not a continuous, something that we're trying to estimate. So here we're just trying to make recommendations based on some other stuff. We really have no target in mind. It's an unsupervised task. Okay. In fact, we'll either do, it'll either be a clustering or an association task that we'll learn spring break-ish. You gave it away. That's all right. It's so hard to just get right there. So identifying a network data packet is dangerous, whether it's a virus or a hacker attack, based on a comparison to other packets whose threat status is known. So you guys good with supervised? There's a target variable you're trying to decide, is it dangerous or not? Or you could be trying to decide if it's a virus or a hacker attack, which type of danger is it? So either way, supervised, classification or estimation? Classification. And the last one we had our setup of our prestigious university has been tracking students for many years in our MBA program for the purpose of building a model to predict success. Graduates have been placed in 3 categories: underperforming, average, and top performing. Extensive studies identified a number of significant predictors. What task are we using? So if you're going to say estimation, what would you be estimating?
I said basically like the categories would be determined based on, because like your level of success after graduating is really in reality like a continuous variable, and then you're just superficially applying the categories after just for like human judgment to use them more practically.
And if you say something like that, that I'm going to assume that I'm not doing 3 categories, but I'm doing this continuous variable, it's like a 1-point question, I'll probably give you like 0.99.
Because it does just kind of depend on how you actually do it.
Absolutely.
Because, right, if you assign a score and then a range of scores fits into one of those categories, like, is that then? Yes.
And so this is where it comes down to setup, and it comes down to how you guys interpret the question. And this is where, so for the above things, I tried to make it as clear as possible. There definitely was a target, or there really wasn't a target. Here they're a little more flexible. The answer I was going for, here are the 3 categories. Classification, you have a target variable, it's categorical. That was my intent of the question. However, if you take it that step further and get to explain, well, I think it's a continuous, and then we just grouped it, I'll give you most of the ones. Okay, so a lot of the stuff, we talked about this last week, a lot of the stuff in this class is how you explain it. Okay. If you would have, not that you had the option, so it's either a yes or no, right? But on the one that I had as unsupervised, if you would have said the target variable that I'm looking at is this, then you could convince me that you should be doing a supervised test. Okay, so right now we're just kind of talking about these very big, broad terms. But as we start to go and get into more of the methodologies, then you'll really start to see why we're doing it.
Yeah, there are two questions related to this. First one, I'm not very convinced myself, but what if I want to ask what percentage of students really made it to success? Would that be
A
what's
descriptive task.
descriptive? So,
Okay, you're just doing a descriptive. What percentage of it is just a descriptive task?
but if I say what's the probability of me or students succeeding?
Then you would probably be doing a supervised estimation test. Depending on how you say that, it could still be, if you're just looking at success versus failure, it's still a classification test. But if you want to attach a probability to it, then you'll start to take like a logistic regression approach as opposed to a decision tree approach. Because you're like, I want a probability about this categorical thing versus I just want to see how the categories play out. And so this is where you'll start to learn all the different methodologies depending on what kind of result you're interested in.
So the fact that it is prediction does not imply that it is estimation. It's a kind of misnomer, the word estimation.
And so this is where the book and I really disagree. The book likes to use prediction to mean estimation. I like to use prediction to mean either classification or estimation, just something in the future. Right? So as we start asking business questions later on, you're going to start to say, well, let's predict if somebody's going to succeed or fail. Well, it's a prediction task because that's our whole big goal, is to try to predict what happens next. But the actual target variable we're looking at is categorical. Are they going to succeed or are they going to fail? So I try to go more with the estimation categorical, or the estimation classification, as opposed to prediction. If you use prediction and you explain it, I'm pretty lenient on that because the book says both. You'll see times where I'll actually put estimation / prediction. But for the most part, I try to stick with estimation and classification just for clarification purposes. Again, it's a terminology thing.
I'm asking more in the sense that the question is to predict success, right?
Yes.
So the very fact that it is predict indicates that it has to be estimation. That's how I thought about it. Can't be classification. So in fact, what I wrote was that they have been using classification till now, but to predict they'll be using estimation.
And so you can still predict using classification. But that's where I was kind of saying, like, the misnomer, that's why I'm really nice as we start out this process. Because it does, like, everything you've been reading your text, they use prediction to mean estimation. It starts to get a little hairy once we start to get into the classification piece, and then we still start trying to say, well, hey, let's predict if we should decide if somebody should get a loan or not, or if somebody's going to pass or fail, and you're still using that word like, let's predict this, because that's our goal. We're going to get new data, and we're trying to predict outcomes, but we're not necessarily having to predict a value. And so different text sections where you'll say different things. Right now, as we're starting, I'm good either way. But eventually, I just like to use the estimation to talk about numbers and the classification to talk about categorical stuff, just to make it a little more. Yes.
Coming back to supervised and unsupervised.
Yes.
So, for the question about the virus.
Yes.
So, what I thought was unsupervised is where we just look through everything, and supervised is where we know what exactly to look. So, if we look at that virus thing, so ideally we shouldn't look at some set things while detecting if it's a virus or not.
So the thing to focus
Confuses
on.
me if we should go just by the words to say if it's a virus or not a virus. That would be supervised, and if we just think like what all factors would be considered, like if it's a crawler or anything like that, like there can be different things in a virus.
But so all of those things are going to be the predictors, right? Your independent variables. Whereas to decide if it's going to be supervised or unsupervised, the only thing you're looking at is the target. So there may be a whole bunch of other things that lead into it, but ultimately we're deciding either is it a virus or is it not a virus, or is it this type of virus or this other type of virus. So all the things that you can think of that go into it, great, and they can be continuous and categorical, and you can be searching for them and all sorts of different things. But as far as trying to make that determination of if we're going to use a supervised or unsupervised task, does it have a target variable that we're going to look at? Does that make sense? And it will start to make more sense. So this week we're still doing visualization, so we're really being pretty unsupervised. We're kind of in that middle ground. Next week we'll get into supervised data mining tasks, and we'll do a linear regression. The next week we'll do logistic regression, and you'll really see the difference between why it's supervised and why it's not. So for now, it's just kind of a big picture as we talked about it. We've got a framework to start putting things in. And then as we go throughout the semester, we'll use this vocabulary extensively. Other questions? Is it helpful to see this? Great. So I'm not providing feedback on your quiz because I just did it. So your quizzes will be graded really fast today. Absolutely quickly, really quickly. Right. Other questions? Good. So, the plans for the rest of the day. You guys have been working on assignment 1. As I said last week, yes, I will keep the idea of your assignments are due at midnight tonight, or 11:59, whatever. It wasn't set that way, so I fixed it. Now it is set that way. Anytime you guys see something like that, just send me an email. I'll fix it. Not a big deal. I will do my best to get everything up and going and all in the right spot, but you know what it's supposed to be. And so if Blackboard says something weird, just talk to teachers. What are you thinking? I'll get it fixed. Not a problem. So we'll discuss assignment 1. I brought the big stickies. It's the beginning of the semester. We get to play with big stickies. It makes me happy. You're not talking about it this time. We're going to demo some more software. So last time we talked about SAS Enterprise Guide. So today we'll demo a little bit in SPSS Modeler and SAS Via. We'll talk about data exploration, data visualization. So assignment 1 is helping us kind of with the data cleaning aspect. Kind of content for today is mostly data exploration, data visualization. I'll intro assignment 2. The great thing for you all is that my Saturday class is a week ahead, so all the pitfalls that they run into over the week, I can be like, okay, so here's the tutorial. And you get it, so it's going to be like a nicer, easier experience for you. So, and then at the very end of class, just in the last 2 minutes or so, get in our groups for our data mining project. Okay. All right, so here we go. Where we've been, all those things we've already talked about on the quiz, so that was great. And then the other big thing we talked about last week was our data mining methodologies. Right? So we're going to be focusing on, today is really more about the data preparation phase. We're going to be prepping our churn data. And then we'll look at the data understanding phase where we're kind of doing some exploratory data analysis and some visualization. So that's going to be our focus for today. So over in the CMA, we're going to be working on kind of that explore. It's going to be our big place that we play if we were in SAS. No, SAS again. So where we are today, I already said that. So assignment 1, so we're just going to kind of start out, we're going to focus on the data cleaning. So since we're doing machine learning, since we're doing data mining, having good data and good data quality is going to be a really key thing, right? Because if you have bad data and you're training a model with bad data, then we're going to get bad results. Okay? So we talked a little bit about data cleaning last semester. You have SASE, your query builder, you can change variables, all sorts of things. This semester, we're going to add some new tools to our toolbox, so not just changing things manually, but we're going to be able to impute data. When I say impute, do you guys know what I mean?
Yeah, update.
Do what?
Update.
Update, kinda. Give me another word. I'll go a step further than update, and I'll say fill in the blanks. Right? So we impute a lot when we have missing data, right? So it's not just necessarily like update, like refresh, but it's like, so we have missing data. How do we handle missing data? And imputing is one of those ways. So what I want to do is early, get up, we're going to get out of our seats. So for your first assignment, that's due tonight, you've been working on it. At least opened it up and looked at it. Okay. You've at least been looking at it a little bit. You have this churn data set. Not the most relevant of all telecom data sets. I acknowledge that. I actually was going to give you a more up-to-date telecom data set, and I have one if you want to play with it. But the more I looked at what I kind of want to do with this, it's kind of nice having something a little older than there. So you have your churn data set, and what we're going to do to start out with, how many of you guys are here? 21, so somebody quick, 21 divided by 4. It's about 5. So, I've got 4 pieces of paper. Once you see where I put them up, so I don't even know where I put them. 4, 5, 4 groups of 5. So about 5 of you at each paper. So I'll have one over here, back on those back ones. Get up, move around, go find a piece of paper. Move so fast. I don't care who you're with, you guys know each other really well already. If you want to try and find somebody you don't normally talk to, you're welcome to do that. If you want to stay with your buddies. Today, I'm going to let you stay with your buddies. You know you're walking all around the room. It really doesn't matter.
We'll start off.
Alright. Smells good. Alright, smells good or writes good? Smells good. Big color. Not. That's going to be like right, Carrie? Orange. Alright. Smells good or writes good?
It's really
Okay. So, questions that I have. So, whoever's up first on, let's get that for a second. On your board at the top, write the word errors. You, business questions. You can put BQ if you want to. You go risk, or do assumptions. And you do want to know. You don't have to write the whole thing, just want to know.
Yes.
So I
What is
Google
churn?
word
What do we want to know? The definition of churn. That would be a great thing. I had that same question when I did it.
I knew that.
All right. So the first thing we're going to do, you've got 2 minutes. The idea is, hopefully you kind of started your assignment. You're going to write down all the errors that you can remember.
Okay.
You guys, I didn't ask you, I did. One of your questions is write some business questions. So come up with some business questions. Just write some down. Any assumptions that you made while you were doing the assignment? Good, bad, in between. Just as you were going through it, any assumptions you made. Anything you still want to know, like as you were going along, like, what does churn mean? Great, want to know, right? All right, so you got 2 minutes. On your mark, get set. Everything you can remember.
negative about okay, I can't bring that up.
And with an invalid state.
Yeah.
Yeah.
We looked it up last class. It's such a postcard abbreviation. But if you look at the abbreviation for the state,
There's
so many values.
inconsistent value.
Also, extreme large numbers.
Yeah,
30,000 or 40,000.
Yeah, I was like, there's
4,000 are actual calls.
I mean, considering no, but charges $5.
There was one that was like, oh, they scrapped that small point, and then there was another one.
Like the question category understand the relation to, I think we're how much of holding out for
Yeah, I know. Good.
Yeah, but I was thinking the same thing. Can't believe they can work good.
New York.
Yeah.
Yeah.
I was like, if she's going to do all I know is that every single one of them. All I know is that every single one of them.
Alright, finish up that thought. Alright, so let's see how we can make this happen. Let's take, you guys are going here. You guys are going here. You're going there. And back group, you're headed there. So we're moving clockwise.
Yes or no means.
I was trying to, how can we, without giving too much. Yeah, keep your marker. Keep your marker. As long as you're still writing well. Alright, now you have a minute and 50 seconds. I did. You get to add, edit, delete, emphasize, whatever you want to do. So if you like it, smiley faces, check marks. If you want to add new things, go for it. You got a minute and 50 seconds. Yeah.
Yeah, it's probably better for this. So, the question that I had was,
I was wondering if that was L1.
I say that
That's really what I
Yeah,
said.
like in like a
instead of valid,
Yeah.
There's only three. Every city has only 3 areas. Yeah. That's all I thought. That was one of the areas.
That was yeah, it's like how
It's 50 states, they all have.
And I was like, how can that come on?
Maybe the lights are really different. But they were like charged. Whatever the chart you're thinking of, is to return that to
It's evening and night, that was an evening.
Do you reflect the 7?
Alright, go ahead and finish up that thought. You guys are like, this one everybody's like, we're done. It's early. Everybody else is having like these in-depth discussions. And you're like, never negative Alright. Was that too fast? Apparently, since you guys are all still talking. Alright, we'll go back in 2 minutes. I have to count. Alright, so go ahead and finish that writing up. We're moving clockwise. So you guys are headed there, you guys are headed around, across. It's the best I can do. You know, we were scheduled to be in the fun 222 with all the good pods and the videos everywhere, and Professor Mullins, that's all I'm saying. Alright, 2 minutes, same thing. Add, edit, delete, emphasize, whatever you want to do.
So like it's tracking how you
I wonder if German should be based on the years to get yeah.
That's kind of like our contributions.
Wait, what?
Oh, it could be new shoes.
If you're right, like our ISYS combination.
Yeah. But that could be an issue. Or it could be.
The area codes.
Yeah, I think they included.
But now that they're cell phones that these companies work it out so that when you need to your number.
So really, like, the area code is where you got the phone number.
Or that, I think it has an actual
Yeah.
Right. I'm thinking, so that, and thinking too about what she said over there, how or does accounting impact?
Alright, finish up that thought.
That doesn't count.
We've got one more to go to, right? Alright. You're like, no, we're done, we're good. No, you're not.
Doesn't count.
Alright, so go ahead and go to your next.
Any of the data.
So we're going clockwise.
Rates.
Errors. Conditions question. Assumption. The purple group's just slowing stuff up. Okay. Alright. One more time. You guys are having some fun conversations. I like it. Alright. 2 minutes. On your mark. Get set. Add, edit, delete, or emphasize.
Yeah, that's what I have.
Yeah.
The area code, does the state refer to the BED?
There were a couple. There was like a negative service.
It goes back to three area codes. And then so many cities. So
And do you remember the because the moment for the information
Well, like I'm assuming that it's a lot of the stuff we'll put together. Yeah, I didn't really have
Alright, start to finish up your conversation.
You might have to stop.
Yeah. Great question. Alright. So go ahead and for our last step, go back to where you started and see what people had to say. Did they add? Did they edit? Did they delete? Did they emphasize and really like what you did? Something is happening back there with the account link. I don't know what it is, but something's really going on back there. Alright, so go back to yours. Go to yours. So go back to yours. See what people had to say. They added, they edited, they deleted.
I guess that's got it. Yeah. Because it counted.
Yeah.
Right. And I did see.
I think it may be a smiley face. It's a weird smiley face.
Yeah, they tried to correct their grammar. And they were no. Actually, you know what?
I just got a really color.
Yeah.
Technicality.
Look, I like it. I get into details.
Actually, I'm not done. No, actually, I'm not done. I could do it again. Go ahead.
All right. So now my question becomes, what type of errors did you guys find? Did the class find?
A lot.
A lot. So what were some of the big ones? Negative numbers.
A fake state, WN.
A fake state?
Yeah.
WN, no state.
Yeah, there's one.
It's not a state. It's actually what it is.
I know what it is.
You know what it is?
Yeah, we looked it up.
Okay. And what is it?
The power of Google. It's the nautical abbreviation for the state of Washington.
It's a Coast Guard code.
But those Coast Guard codes don't make any sense.
Not at all.
There's also overlap, so you can't trust that this is the only error necessarily.
I like it. So what else do we have? Inconsistent.
Categorization.
So like true versus yes, false versus no, all that stuff.
Everything in the chart.
Everything in the turn column.
There are a lot of like really big outliers too.
Yes.
So maybe 4,000 calls.
I mean, they kind of.
What do we have? What's the time period?
So they worked hard. So that was the fun next thing, right? So is it so that's one of our assumptions back there, right? Is it a month? Is it a day? Is it a week? at least I think I assume it was a month.
No, good anything.
Assume it was a month. Maybe most people assume it was a month.
Like it's not then it's what is going on. Typically, one would want to say churn, field, what is the international plan? All of them to be say either true or false, the rest are no. Each one says.
Yep. I mean, I'm not going to say that I went in and made data dirty just so you guys would have to clean it. But I went in and made the data dirty so you guys would have to clean it. So this is a data set that's been used for quite a while. The textbook that we use for our data mining class in undergrad is one of the examples that they use. If you get on Kaggle, you'll be able to search and find this particular data set. It's out there. But then yes, we intentionally dirtied it just for the purpose of.
Thank you.
You're welcome.
Appreciate it.
So, but having the negative values, having the inconsistencies, these are the things that we have to look for, right? So we did it on a small scale, but if I was merging two different data sets, or if I was very more likely merging two different cellular companies, I'm not saying that doesn't happen all the time, right? You've got data coming from different places, somebody may use yes, no, somebody else true, false. What else do we have? Anything good we need to...
It says that area code, we found only 3 area codes, but or more than 50 states, but we do have a question. Does the area code, does the state actually say that where the phone is being used, or it refers to the area code? Because it could be that it's used in a different state.
So is that one of our assumptions that we wrote down? Did anybody else write that down?
I know it was on the one to
Wow.
I think it's
So
on
does anyone want to know any assumptions?
There's a lot on the want to know. So.
So I did this in my Saturday class, and they're like, "Yeah, we want to," and I'm like, "You guys are, man, okay, we want to know a lot of stuff. I know some of the answers because I did it. Some of the answers I don't know, but we'll make up." So, and to answer that question, let's actually hold that thought because I have a question for you guys. And an inconsistent rounding, we can work with inconsistent rounding. That's just yeah.
The reason we asked that question was, what if it's used in a different, like I have a California number, but I've been using it here, and I happen to make a lot of service calls. The reason I make service calls is the service here is bad. It's not like California or wherever, Fremont or wherever, the number, the area code, there the service is bad. That's not the case, but maybe in Bentonville, the service is bad, and therefore, so it kind of.
So this comes to our business question, right? Like
Yes.
what is our business question? So let's see what some of our business questions are. Okay, somebody from this group. Tell us that was my fault. Bad instructions.
Can you predict churn? Can you list the factors which predict churn?
So that was like the smiley face. That was the top one. That is the ultimate goal on week 4. It's going to be, can we use this data and so really, is it a supervised or an unsupervised task? Do we have a target variable? Sure. So what are we trying to predict? So we have a target variable, so supervised or unsupervised? Supervised. Right, so even though there's a lot of things that that's going to go into it from the predictor side, from the target side, we have a target, we're predicting churn, and this is where that predict word gets a little weird, right? Because you guys wrote, can you predict churn? But if you think predict and estimation, then you're like, well, no, I don't have a number that goes with churn, it's a yes or no. So, yeah, so it's going to be is it an estimation or classification task? Classification. And the first classification methodology we're going to learn is logistic regression. So we'll use logistic regression to figure out if we can predict churn. What else can we try to do, or business questions we want to answer?
What proportion of customers have international plan, email plan?
Okay, so if we did that one, is that a data mining? Is it a descriptive? Just a descriptive, right? Good. We still need to do descriptives, right? Very valid business question. Keep going.
What's the most profitable time of day, morning, evening, or night?
Okay.
Average number of international calls without international plan. Who can we target by international calls?
Okay, so the idea of can we use this to actually gain some insight and do something with it? Good.
Would bundling international email plans prevent churn?
So some of these are data mining questions. Some of these are just descriptive questions. Both are going to be very valuable as we go through these next 3 weeks. Alright, so what assumptions were we making?
We assume that customers only have one phone number.
Excellent.
Customers did not change their plans during the span of time the data was collected.
Right.
The time measurement of the data being collected is over the span of a month. Charges are in dollars. Customers did not change area codes any time the data was collected. And day, night, evening rates are all different. Someone had same crossed out and put different.
Same, different, same, different. There's something happening with the rates. Okay.
And someone put churn equals customer turnover.
Yes. So that is going to be, so our assumption is that, and then I want to know, what does churn mean? Yes, the idea of churn is whether somebody stays with your company or somebody leaves your company. That's a big idea behind churn.
Yes, churn means they leave.
So yes, churn, they leave. No, churn, they don't. Right, so even the next step of what do we want to know, is it yes or no? So, what's the very first thing that you guys said?
Data dictionary.
Wouldn't that have been nice if I would have given you this beforehand?
I mean, how does it go into the account? Like,
So that was actually a really great question when you guys were like, account link, what is this, what is this? So, last year's group is actually who created the data dictionary. So the data dictionary does not exist. I actually reached out to the textbook author who actually was using this in his textbook. I'm like, hey, can you give us a data dictionary so we can know what's going on? He's like, yeah, I really don't know. He's like, but I found the data here. And so I go here. And they're like, we don't support that data set anymore, but it's over here. So I went over here. And I'm like, hey, do you guys have the data? No, we just kind of assume it's just kind of a class data set. So whatever you want to make it up, that's just fine. So for account length, we can assume, we can look at it here in a few minutes, and we can make our own assumption, and we'll fill in that blank. So we'll figure out what account length is for us. What else do we have? Or what do we want to know?
Are negative values valid for charges? A lot of people are.
So let's ask that question. What do you think?
Give me a refund.
Yeah, a refund or reimbursement.
But typically refunds go to you have a billing system.
Given the data set that we have, do we like negative numbers or not?
No.
No.
It's not a transactional.
Because it's not a transactional thing, right? So right now, let's say negative numbers are bad. Okay. So that's an assumption we're going to make. So moving forward, negative numbers are bad. Brilliant. What else?
People seem to be curious about the area codes and why there's only 3 in like 50 states or 50, whatever.
So is there a business scenario that we can think of?
Like the company being based in like California, I think customers move in, and then that's why they contact their customers.
I mean, you guys okay with that idea? So you could go at it multiple different ways. You could just be like, area code's bad. I'm not going to use area codes. Don't need location. Or you could just use state. Or you can see where the area codes and how they're dispersed between the states. Right, so think about, and the reason I'm saying this is we're going to use the same data set for assignment 2 and assignment 3. So you're going to have the time to get into the data set, and you're going to be making your own assumptions. Okay? Your assumptions do not have to be the same as your neighbor's assumptions. You just have to state what your assumptions are. So if you really wanted to say that negative numbers were okay, say negative numbers are okay, and here's why. Great, move on. But if you try to compare means with someone else, they're not going to be the same. Right. If you just like the area code, or if you just like the state, pick one. Go with it. See what happens. I kind of like I like the idea, Matt. That was kind of the best one that we could come up with. Is like, it's based out of one place and they've moved, but they've kept their number. Right? You have a California number. How many of you guys actually have an Arkansas number? That helps, right? Yeah. Right, so that's half the class, right, has an Arkansas number. The other half of the class doesn't have an Arkansas number. Okay. So that could probably be something. What other things do we want to know?
What happens when customers change number but stay with company?
Okay.
Like, if we assume that there's only one number per customer, how do they update that change?
So going more back into the kind of the database question of how is that being accounted for. So if we make the assumption over here that I love the thing that they kept saying was for the time the data was collected, we are making these assumptions, right? So the customer may have made changes, but for this month, assuming we have a month of data, for this month, everything stays the same. Nobody's changed anything.
A lot of the questions are like whether any special conditions, like different charges for people with certain plans or different length of time, stuff like that. So, like any special qualifications that would affect rates.
And so we're looking at this on the back end, right? So all we have are the data. We don't have the pricing plans. We don't have things like that. So next week, we already know how to do multiple regression, right? So could we take data that we have in our data set and actually predict what the charges are? We've got minutes, we've got how much they were charged. We have different things, so that's actually one of the things we'll do in class, is just see, can we figure out what the charges are by using a linear regression model? Because we're assuming that this is we'll see, does it fit a linear model, or is it maybe nights are linear and evenings are, we should love the nights and the evenings. Have you guys actually had a plan where you actually had to care about nights and evenings?
Not now, but
Maybe. Well, not now.
Yeah,
Like,
high school, middle school.
yeah.
Throwback.
Yeah. Yeah, when I first got my cell phone, it was a very big deal. You're like, okay, 7 o'clock from singular, which is no longer singular, it's AT&T now. Yeah, there you go. 7 o'clock was the time that it went from evening to night, and you're like, ooh, free nighttime calls.
Yeah.
You have to get charged like Prime during the evening. Oh yeah. You have to care when you call people. But anyway, so we'll start trying to figure out kind of like what this is and then what can we do with it.
So are we going to predict international charges also?
Sure, why not? Right, and maybe they follow something linear or maybe they don't. So we're just going to find out, right? Is it going to be a linear model that'll work or is it not? That's what we'll do next week. All right, go back to your chairs. So I will snap pictures of these during the break. I will add them to, oh, thank you for turning to smell good lunches. Thank you. I will add them to the blank spaces. Really good. I don't know. So, do you guys like the brainstorming charts?
Sure.
Okay. Sometimes. We don't do it sometimes. The honest one, actually. If you like it, then we'll do more of it, and if you don't like it, then I'll do other things. Okay, I've got a big toolbox of things we can do. Alright. So I have a, this is what I think the errors are. So you'll be able to see this when you go back and look at it. You've got pretty much everything I thought you should. You got some potential data entry outliers. You've got the correct abbreviation state. The area code, there's only 3. Again, you come up with the business question that makes sense. It's not an error. Or you don't come up with a business question that makes sense, and it's a data error. The trues to falses, yes to nos, positive values, outliers. I mean, so the things that you guys already really found. So some of you have had jobs, some of you haven't. Some of you have had internships, some of you haven't. Did you ever run into dirty data in the job that you were working at? What did you do? How did you handle it? Well, but how did you clean it? Yes. How did you clean it? Yeah.
Like make pivot charts of like what was fine, what was inconsistent, and then go back and like normalize it with like Excel functions and stuff like that.
So normalize. I like that word.
Manually go in. Yeah.
So you're like, I'm just going to go in, I'm going to figure out what's wrong, I'm going to go fix it. Okay. And on our small little data sets, sure. Right? How did you guys find the errors? So first of all, what software did you use to find the errors? How many of you guys use Excel? How many use Excel? How many use something other than Excel?
Excel and SAS.
Excel and just use SAS.
Alright.
You guys use SAS? Mostly Excel. You're Python. Mostly Excel. And that was fine. I mean, the directions said you could do it, right? It said you can use whatever, right? You can use Python. So whatever you wanted to use to actually find the errors. This next assignment is going to be coming up. We'll talk about it in the class. It's assignment 2. Now that you have found the errors, get you to do an assignment 2. Fix the errors. Right, so you're going to fix the errors, because then once you fix the errors, guess what you're going to use for assignment 3? The cleaning stuff that you fixed, right? So what we've tried to do for these first 3 assignments is kind of step you through in baby steps what you're going to be doing in the rest of your assignments, right? So we'll assume that you look at the data and that you clean anything that needs to be cleaned, that you pre-process, that you go through the data preparation phase. Now, most of the data that we're going to work with is not going to be as intentionally dirty as this one is, right? I'm not going to focus on data cleaning, but there will be some stuff that you're definitely going to want to look at. And then you'll go through the data understanding process, where we're going to do the visualization, which is what we do in assignment 2, before you actually get to your modeling, which would be the assignment 3 piece. So, like I said, I'll go ahead and take pictures of these. I'll put them on here, so that way we can use it. So, the next thing we're going to talk about is moving into the idea of, once we have data, visualization helps us in 2 ways. Right? Visualization can help us find errors, and then once we find errors, it can help us tell our story. Don't think you're getting out of telling your story. Still storytelling. Step 1, business understanding. What is our business question? If you have a business question, that's going to aid you as you go down your data exploration path. Okay. So let's say we have no idea what account leaf is, but if none of our business questions address account leaf, then do we care to dig into that variable? Do we need to figure it out? Do we need to chart it and visualize it necessarily? If we don't care, then that's not something we have to worry about. If I'm only interested in, if we stay with this data set, if I don't care about customer service calls, all I care about are just the calls that people make to other people, not to customer service, then do I really care if there are negative values in my customer service calls? Right, that's not something I have to go and fix necessarily. You want to make sure that the data that you're using is clean and good. The variables that you're using make sense. But just because I give it to you in a data set, do you have to use the variable?
No.
Thank you. No, you don't. Right? So, one of the data sets that I actually started looking at, I got off of Kaggle. It's a telecom data set. It has 100 variables. You're not going to model 100 variables. You don't necessarily want to explore 100 variables. You want to have some business guiding idea inside. Okay. So which one should I pick? I told you, we kind of saw the big pulled out one last time. This week we're going to start with visualization. And most of the time I put the visualization in the unsupervised category. We do not have to have a target variable. If we have a target variable, we can use it. So visualization can kind of in the middle. But really I kind of put the visualization kind of in the unsupervised category. So when you think of visualization, what kind of visualizations do you guys think of?
Pie charts.
Pie chart. You do that just because you know I don't
The
like
best of visualizations, pie
it.
charts.
Pie charts. Everybody loves the pie chart. So I know we talked about visualization last semester. But we did it on a little bit smaller data sets. So now we're going to think about it with bigger data. Pie charts. Okay. What other visualizations do you think of?
Break comics.
What?
The break comics.
The break comics. You're awesome.
Oh, yeah.
The break comic. Right? It's a visualization, right? Box plots.
Bar charts.
Bar charts.
Heat maps.
Heat maps. I like that.
Graphical maps.
Geographical.
Scatter plots.
Scatter plots. Histograms. Line chart.
Area charts.
Area chart.
Well, we just pull it up lower, but there's more donuts.
Stacked, it can be zero.
Radar distribution.
Radar distribution. You know, I actually have one of those on one of my examples, so I'm going to put that one down. Oh, there you go. Radar distribution.
Bubble charts.
Bubble charts. Oh, we got to love the bubbles.
There's something called a waterfall chart.
Waterfall chart. Okay, so the point is, we've got a lot of visualizations, right? But you still, the very first, anytime I say visualization, people say pie charts. And the pie charts have their place. They also don't have their place. So, my thought for just a little bit would be to kind of look at some visualizations, kind of see what they're telling us, and then kind of talk about, you know, kind of the good and bad characteristics of visualization. So like I said, I know we've done this before, so we're going to do this at kind of like a high level, and then we're just going to get into our software and start making visualizations and seeing what we like and what we don't. So the first thing, let's do this. So I'm teaching an undergrad class this semester. The class that I taught you last semester, I'm doing it for undergrads this semester. Right? I'm not saying it's fun, but it's been fun so far. But I showed this video to them, and so I thought I'd show it to you guys. And why Internet Explorer is the default. Well, let's see how loud this is. You guys see that? It's called the long run.
Stop. Hurt yourself.
I'm not trying to sell you a garment or anything, but
How does he
But-
get back?
that's why she picked him up in the car. We're good.
I know.
But so, kind of the reason I wanted to show that was just to, I mean, you guys have talked big data in your other classes, right? So we're not going to get into a big data discussion here. But with the analytics aspect of it, visualization is becoming a really big thing with big data, right? And so the more data that we have, and the fact that we're collecting data from all over the place, being able to visualize that you're finding and you're doing that data mining and you're finding trends and things that you never expected or never even thought to look for. That's one of the cool things I think about the data mining is you're finding answers to questions that you never knew you had, right? So when we talk about having a business question, right, our business question can be as generic as, here's this one, what are the data telling you?
No.
You thought you were done with that one, didn't you?
I never did.
So, Fitbit has been collecting data on every single wearer of Fitbit. And as they've been collecting data, right, ideally, it's anonymized data. It's not like they're selling it off to people like other companies. Let's not hear the TurboTax commercial. It is that time of year. We'd like to be able to scroll past them.
Wow.
So, Fitbit's 150 billion hours of heart data reveals secrets about health. I knew it was gonna Okay, so they have health data. So Fitbit is tracking all this information about all these people and who wears a Fitbit. Like, you don't have to tell me who wears a Fitbit. But the demographic of people who wear Fitbits, right? Kids wear Fitbits. Teenagers, college students, business people, retired people, right? You pick it, they wear Fitbits. So they have data from a very large range of people, right? They have 150 billion hours of data. And this is of the heart rate data, right? So not even just your steps, but you've got the heart rate data. And as I start to look at it, what they actually found was that resting heart rate is actually one of the best predictors of your overall health. Your resting heart rate. So as we start to look, I always forget to, story continues. Right? Simple thing. Resting heart rate by age. We're looking at age 20 to 80. And what can you tell?
Women appear to have a higher resting heart rate than men.
Women have a higher resting heart rate than men.
As you age, your resting heart rate actually appears to get lower as well.
Right. So for men, you can see this really well, right? So for men, it's really, your resting heart rate goes up until your 50s, and then it goes back down. Women, it's kind of, you're up there just all to begin with, right? There's no real gradual up and down. Right? That's something that nobody had ever really noticed before. Because think about how medical research has had to been done in the past. Right? You wouldn't have had that much. Right? you had to have somebody, and they had to come in, and you had to check things, or you had to rely on them recording at appropriate intervals, right? Okay, so I'm walking, here's my heart rate, I'm resting, so you have to measure this, you have to trust all this information. You're gathering on very small samples, and so they never really noticed, I say they, the medical community hadn't really noticed significantly that people had, that their heart rate goes up, their resting heart rate goes up, and then it comes back down. Right? There's all sorts of other things that could potentially been involved. So your BMI. Right, so your BMI on the x-axis, your resting heart rate on the y. So same trend holds, women's higher than men. What do you like? What do you like, or what do you not like about this graph? About this visualization? If you were to make this graph, what would you do? Would you do anything different? Would it be the same? Get picky.
I mean, I don't know medically, but it doesn't seem like there's that big of like an interval, like in the BPM, like 62 to 72 is only like a distance of 10. So like the distance between each of those little points is really like blown out of proportion.
Okay.
I mean, maybe a difference of 2 BPM is relevant, but as someone without medical knowledge, it doesn't seem as.
So is 10 points a big deal?
Yeah.
Yeah. That's a good point. Right, so a little sub-note of what a difference of potentially 2 beats per minute, how does that affect your health?
I'm kind of confused as to what this big old line is on the first point, and why there aren't any other lines stemming from the other points.
There's a couple small ones.
Yeah.
Second data point should does, and the last data point has one.
So there's a little bit here, there's a little bit there, right? So right here, all it says is just BMI and resting heart rate. It doesn't tell you if it's which it wouldn't make sense to be a sum, but it doesn't tell you that it's the average resting heart rate, right, for all these 150 billion hours. So this, my assumption, is this is actually a histogram. I mean, it's not, but it's like, it's got your kind of your upper and lower limits. So right here, the variability when you have a really, really low BMI is pretty big, but once you start to get up here, then the average is pretty average. Right, it's the great thing that I do like about this is like, it's healthiest not to be overweight, but underweight might not be healthy either. Right, so there's like that one sentence like this right here, the thing that I want you to get, or that they wanted you to get out of this, right? It's got a title, right? So we have a title. We at least know what these things are. Wait, do you like the colors? Don't like the colors? Don't like the colors. So why don't we like the colors? Why does it have to be pink? Why does it have to be pink? All right, women are pink, men are blue. It's just the way it is. Right? Keep that, or I'm going to come back to that one, so keep that. Okay. But I do like the idea that right here there is a nice, just one little, this is the insight I want you to get from the graph. Let's try this one. Oh, this is the one that I like the best. We have resting heart rate with exercise. Again, we're assuming the average resting heart rate. Here, everybody has little lines. Weekly active minutes.
So if I were,
What exactly constitutes?
It says within the article.
Okay.
I think it's just under the wall. Yeah, it's pretty.
I worked out for that.
This is funny, right? Like if you do more exercise, or if your BMI is good, then your heart rate is low. Also, if your age is high, your heart rate is low. So you're healthier if you're older, above 80. Is what you mean?
I mean, not necessarily, but yes. Because that's one of the questions. Well, and that's actually one of the questions that they had in this article. It's like, why does your BMI or why does your heart rate go down as your age goes up? And a lot of their assumption is that older people are on medication to help with X, Y, and Z that brings down their heart rate.
But it's not drastic, right? It's a very smooth.
Right, so you potentially have more medicine, you've got more of the beta blockers, you've got things that are actually trying to, you're taking that baby aspirin a day to help with heart health, it's things like that.
But that should be more abrupt, right? It's so smooth. The way it comes. Like after 50, it's smoothly comes.
I don't know.
I mean, your metabolism can slow down, right?
It could, yeah.
How accurate is the data? Because they're not like medical grade devices like that's for them.
Right.
I don't know what you said.
The heart rate sensitivity active is the dominant more accurate.
So it kind of goes back to, is it, like, would I publish this in a medical journal? Probably not. But would I get insight to know what the medical people need to say? Probably so.
I read an article in the news and they were talking about the heart rate sensors not like they're not. The variance on them
It's too high to
is too great to be really reliable.
And so I think that's kind of where we go with, like, over 150 billion hours, I'd say it probably averages out. But again, I wouldn't, this is published in Yahoo Finance. Is it published in, the Journal of Medical Studies? But now, and one of the things it kind of says in this article is, here's something that the medical community hasn't thought to really study or hasn't had a reason to study, and now they can go study this. So I think that's kind of more where it is, as opposed to, let's go publish this, and let's get something that is more accurate. Yeah, so my big favorite thing about this one is, if we kind of put a little line right here, like, I'm a girl, so we'll put it right here, at like 65 beats per minute. Really, once I hit about 200, 250 active minutes, that's a very negligible, between 250 and 500 minutes. That's only 1 beat per minute. I'm good. I don't gotta work out like crazy. I can just work out. I'm not saying to work out. But if I did work out, it's nice to know that I don't have to go for 500 minutes, that I can, go for a little bit. Right, so regular activity does wonders for your heart up to a point. That was their takeaway from this graph. So we have activity effect on resting heart rate by age. What do you guys think about this one? Change in resting heart rate.
Change from what? The average?
From, let's assume, change from when they started.
Okay, yeah, gotcha.
And then change in daily active minutes. So I'm more active. How does that impact the change in my heart rate?
Goes down.
Do we like this? What do we like? What do we not like?
It's interesting that 25 is in the middle.
Well, we saw the picture.
But the problem is we have number 50.
Do we like the colors?
When you're 25,
You're like, I just don't really like that right there.
because it goes from the middle down and then back up. Like, in terms of age.
The colors kind of all seem the same. Except kind of like the other.
So the colors aren't really distinguishing a whole lot. The lines, which you can't help, but like the labels on the lines, interesting but weird all at the same time.
Well, the farther you go back, it's really hard to trace, like 35 and 45.
Right.
Which one is that?
Which ones? Okay.
Like what happens to 35-year-old who had 170 minutes of daily activity?
That's just something crazy. A little fluke right there. Not really sure. Well, the same thing kind of happened at 75 though. So 170 minutes just
Or even
isn't.
just now.
And this is male and
Right. So we're making an assumption that they're male and female, right? So we put it together. See what else we have. Sleep.
I don't want to sleep.
Sleep.
The amount of sleep that I get is not even on my graph.
So looking at this for your resting heart rate, is it 8 hours hours of sleep, or is it something different? More like 7 hours of sleep.
Doesn't age
That's
affect
not
this?
Do what?
Doesn't age affect this? Like, the younger you are, the more sleep you need.
Yeah, exactly.
So,
We don't know. We don't put the age in here with it. And then again, we start to talk about here with men, it has much more variability the more sleep they get. Here we have activity versus heart rate by country for males. So we've got active minutes per day, resting heart rate. What do we like or don't like about this one?
I like the color for confidence.
Okay. So we like the colors. And so which ones did we really call out? Do you notice?
The outliers have been labeled.
Yeah, the outliers.
Kind of the big outliers. You make sure there's names there.
in the USA.
Right. So why USA, Japan, Australia, China?
The most popular.
Popular, right? Where we have our people from, potentially. Where our users are. So things that you really want to call out, that's where we'll make sure that we try and label. Getting a little more creative with our drafts. So David was the author, and Nikki was his wife. So Fitbit said, yes, you can see our data, our results, but you have to give us information about you. And so he did a nice little compare and contrast with a nice little dashboard, right? So visualizations. His wife's way more active. Yeah. He's way more active. But he gets to sleep. Yeah. He gets to sleep. So you've got kind of some information there.
Yeah, that's good. Do they have anything with height?
They don't. So this one was his life events versus resting heart rate. So kidney stone and holidays. Holidays were apparently not good for his resting heart rate.
Vacations are good.
Vacations are good. Starting to use a treadmill. And here he's getting older, so he's doing something better here.
Family reunions also.
Family reunion. Even when he's doing better, it's still. So that was kind of his conclusion was, yeah, he's like, so basically kidney stones and holidays not good for my, not good for the rest of my work.
So he turns out life.
So, but again, so we just learned a lot about David really quickly. We learned about people in general, right? But so the visualizations that we have, right? We want to make something that's good, that's easy to follow. And one of the things that I want to do, let's do, yep, and then we'll take a break. So we're going to come back to this. So I have a question for you. What do you see? I'm sure you guys have seen this stuff before, but okay. So what is the first thing? Like for you, what is the first thing that you see? How many of you guys see faces? How many see the vase? I have no idea what that means about you. Right, but the idea here is the use of color with space, right? So you've got the faces, the black faces, or the white vase. You've probably seen this one before too, but just because I feel like this one's harder to like get your initial thing.
Woman turning back. There's a woman.
So what do you see here?
Young woman. Young woman.
Okay. So how many of you guys see a young woman?
Oh, there's the old woman.
How many of you guys see an old woman?
Oh, I can see the
So you've got a young woman or an old woman, depending on how you look at it. Right? And sometimes, like, I even know what I'm looking at, and I'm like, oh, where is it?
Where you guys are going.
Right. Is everybody good? Can you see both of them?
Yeah, I can see
No.
those.
So the young woman, right? Young woman, here's her face, here's her bangs, kind of got some hair going on here, right? That's kind of her face, and she's got like a fur coat on or something, right? So that's your young woman. Your old woman, still with the hair, but now it kind of comes down here. Here's her big nose. Kind of comes down more to the chin. And so you've got more like an old woman with a bonnet on. Right, so what do you see? So the use of space, the use of color.
I get that.
You guys heard of Gestalt as far as visualization goes? It's a form of psychology, right? So it's Gestalt psychology. We're going to talk about really quickly the Gestalt laws of group. Oh, I have a video. Okay, so videos, good things. Got it? All right. So Gestalt psychology, the idea here is it focuses on human perception. What do we see, right? So we're going to talk about visualizations. We need to talk about what do people see. And then our goal as the data scientist, our goal as the person doing the visualization, is to make sure the people see what we want them to see. Okay, so we've got 5 major categories. No, you will not be tested on this, FYI. But you've got 5 major categories. Different people keep adding to them, so I think I actually have 7 that we're going to kind of illustrate. But have you ever heard that the whole is greater than the sum of its parts? Totally misquoted. Totally misquoted. The actual quote is from a Gestalt psychologist, and it's the whole is something else than the sum of its parts. And that's the actual quote. He gets really mad when people misquote it. It's actually that the whole is something else than the sum of its parts. So as you start to look at some of these visualization principles, and these laws of kind of like how you just inherently group things together, I have a couple of, I think it's like a 3-minute video. And I have a few slides that will cover. Oh, it's only
If you're human, I'm guessing you saw a light. This idea that we make sense of things by seeing the whole rather than the individual parts is called Gestalt psychology. Its principles are especially important for designers who create complete and compelling visuals. Because of psychologists Max Wertheimer, Kurt Kafka, and Wolfgang Kohler, Gestalt theory can be broken down into 6 design principles. Figure ground. The thought that when you look at a scene, you separate objects so that some of the focus or the figure and others in the background. Similarity. The notion that we place objects with similar characteristics in a group. These characteristics include color, size, font, shape, texture, and more. Proximity. The belief that we group together objects that are close to each other. Closure. The idea that our minds close objects that are not necessarily together, but complete, in order to create a whole. Continuity. The theory that we continue to follow objects that are visually aligned until they are interrupted. Order. The belief that alignment and symmetry are attractive and essential elements of design. When Gestalt principles are ignored, designs tend to look out of place or incomplete, forcing our eyes to focus on little inconsistencies rather than the greater whole. You may not know exactly what seems off, but you will feel something is out of place. The best designs, unintentionally, make the world feel a little less chaotic.
So just a little 2-minute thing. But one of the things that this Gestalt idea, really kind of has going on is it's the law of prognance, or the law of just simplicity. Right? So as we're going to create our visualizations, these are just some things we want to kind of start to keep in our mind. Right? And so you have the layer or the graph on the left versus the graph on the right. Which one do you like better? Right. Okay. So you're arranging data logically and systematically. So there's something to it. Okay. So we've got kind of a line going on here. The law of proximity. Right. So here, try comparing north across the four quarters. So what's my goal? Is my goal to compare quarter 1, 2, 3, and 4? Or is my goal to compare north, the blue one, across all 4 quarters? If it's to compare north, now try this. Now we have all the north group together. Okay, so proximity, right? Know which chart you want us to focus on. What do you want me to look at? If you want me to look at it, make it easy for me to look at it because of how I'm going to group things together. Okay. The law of similarity. Okay. We're the radial chart here. Okay. So here we have total revenue. It breaks out into 3 parts, and then we break the 3 parts out into 2 to 4 more parts. Right? Just kind of showing how things go together, but it's how it's similar and how they fit. So they're all color-coded, and then we can see how the sizes kind of play in. So going with the law of similarity, if these are all salespeople, do we need color, or do we just need it all to be the same color? Does every person need to be a different color? Okay, so use similar characteristics, attributes, right? Color, shape, fonts, things like that, if you want to establish a relationship between your objects. Sometimes colorful is good, sometimes colorful is not as good. Kind of going back to our first, right? So this is a little bit different. It's the law of continuity, right? So align elements linearly as much as possible so we can see that the difference really happens and not have to go bouncing back and forth. The law of the focal point. What do you want me to focus on? Okay. And the left, if I wanted to focus on James, now I'm having to write some text to show you, hey, let's look at James. In the right, who do you look at? James. Assuming that James is the third one. You look at James, okay? Because I've made him a different color. Everything else is the same, but I pulled out what I want you to look at. Okay? The law of isomorphic correspondence. You guys know what isomorphic is? I had to learn it, so it's totally a math. It's not a math term, but we use it in math all the time. And isomorphism is basically something that you have an inverse of. Okay, that returns it back to its original place. They're like, they're similar, right? So here we're going to keep in mind our users and their preconceived notions of past experience. So I'm going to default to popular convention. When I see pink, when I see blue, my automatic thing is male-female. If I would have flipped the colors, which I've seen a bunch of my undergraduate students do, the first thing is defaulted pink, the next thing is defaulted blue. They put males first and females second, and then the whole time you're having to like stop any preconceived notion that you have and really focus on what that graph is. Okay, so I see the pink is higher, but remember the pink's not female, it's actually male, so I've got to remember. And it's harder to look at. You know, for the better or worse, we have preconceived notions. When you see green, what do you think of? Good. Good. When you see red, money. Love it. When you see red, what do you think of? Right? Green and red put together, what am I thinking of? Christmas. Right? Okay. So, but there's things that, like, in your head, you've seen enough that you just have this idea. Okay. The last thing is kind of that figure foreground. Right, so some of it is kind of the examples that we had at the beginning. Other is, do you like the dark blue background or do you like the white background better?
White.
Okay.
Well,
kind of like the dark blue.
okay, well,
You can't read the numbers.
Yeah, so you can't read it. So if we changed, so maybe a combination, right? So maybe I would make these darker against the white.
We have a border of white around the dark blue, which makes it really fun.
So you don't like the white around the blue?
If you're going to be blue, be blue. The whole way.
Right? But here, so what is the contrast, right? Have that good contrast that you can see, right? Yellow on PowerPoint is a bad thing, unless you have a black background. and then yellow stands out pretty well, right? So you have to kind of really play with those colors. And this issue isn't a visual design class, but they are, as we're creating visualizations, let's try and keep some of these things in mind, right? We're going to start to play with Tableau a little bit more this semester. SAS Viya has a really good visual analytics, and you can start to change some of these aspects fairly easily. Okay? In the past, changing colors and stuff was not the easiest thing in the world. Now it's becoming a lot more easy, so it's something we want to kind of try and, I won't say focus on, but keep in mind. So the last one I have is the law of common fate. Right? So things that go together move together, right? So you're kind of using movement to establish things that happen together. Or here, product C, we've got product A, product B, they're going together, they're growing, it's nice. Product C is going the other direction, something's happening. So the law of common fate. Are we moving together or are we moving in opposite directions? But one of the things that I have, so as you all start to look for data sets, there are data sets all everywhere. The internet is full of them. Most of you now have your Python skills. You can go get whatever data you want. You've learned about APIs and you can get data. You've learned about Kaggle data sets. You've learned Google data sets. Google now has a search engine for data sets. Data.world is another place that you can get data sets. In fact, it's where I got your bike sharing data set. Not sure if you remember that. Bike sharing. Might have spent about, I don't know, an hour dealing with that data set. Okay. So really quickly, I was going to pull this up. I'm not going to spend too much time on it. But like, so here's the bike sharing data set. I can make this bigger. There we go. And this is the information that you had. Should look very familiar since I basically copied and pasted for your final exam. This, however, was your data dictionary. That's the data dictionary. I modified it a tiny bit. Hopefully to make it a little bit more readable for your exam. I didn't just give you that chunk. Right, but this is where the data, the attribute information came from. This is the relevant paper where it actually, like the guys actually use this information. And you can actually get into what are the data sets. This is where I got your stuff. The other fun thing that I looked at here, you can actually go to Capital Bike Share. And if you really want their data, you can pay them for it. Or if you're okay with older data, that's why we have 2011 and 2012 data. But they wrote a nice report, an executive summary. 72 pages. Aren't you glad I don't make you do that? By a nice little consulting firm. Just starting out with your executive summary, you got a nice little overview of what's going on. And what's the first thing they really put after the overview? The key conclusions. Right, remember, they use 72 pages. You guys are using one, so, right? They actually use a little bit of, kind of bold and underline, which is all right. Nice whole numbers. All right, if you get sick, close your eyes for a second and do some scrolling. All right, so kind of a nice little executive summary. Then further on down, when you actually get to their report, a lot of tables. Scroll a little bit more. They start to put in the graphs and the visualizations. So what do you think about this visualization? We've been asking that question today. You don't really, you know a little bit about bike share. Different shades of blue, not pink and blue. So you got male and female, but they're both shades of blue. Here you've got the numbers inside the bars. Different font colors, depending on the gradient.
I'm not sure I understand what it's trying.
I've got no idea.
Just the sex distribution.
Of their members
Versus
versus
the regional board.
yeah, who's in who's in DC probably like the regional. So overall, more males use their bike service than females do. So overall in DC, it's about a 50-50 split. But people using our bike share, there's 60% versus 40% of the city. Right, but if you had to ask the question, I'm not really sure what they're saying, is this a good visualization? Is there anything you could do to make it better? And then we start to get some more information, so we start adding in colors. Males under 35, right? So that's your big market. Go a little bit farther. Lots of tables, graphs. A little farther down, there's one that I like. Lots of bar charts and tables, so they weren't real creative with their visualization. Somewhere they used a lot of colors that looked really crazy. This one. Bike share trip purposes by when they join the program. I have no idea what I'm trying to get out of this. Like there's text around it, and can you get information?
Depends on if you have a way to advertise.
Yeah, because they divide some particular locations. So like for social entertainment, putting careful like parks and entertainment districts versus like business areas.
So people aren't really using them to do like exercise and recreation so much. But it is trending up.
The sums of these categories don't add up to 100.
So the sums of these categories don't add up to 100. The sums of these categories don't add up to 100. So what are the numbers?
Yeah.
Multiple responses.
I think that's really what it is. So these are the things that we got to kind of like look at and figure out. And then, I mean, I'm not sure about you guys. I'm not a huge fan of the peach color. They're like light blue, peach, dark blue.
It's a good divider.
So you like, so it's a divider. Right. So are you trying to divide and draw attention to that middle one? Because it's different. It's not blue.
But they're probably not.
That. Right. So like, what's the point? What's the idea behind the color? I mean, I know these are kind of like weird things to talk about in a data mining class, but at the same time, they're not.
I feel like it's more just like we don't want to put another blue in here. Let's put something to separate the
What these categories are like. Is social and entertainment really that different than a restaurant or a meal? Is a personal appointment? There's gonna be a lot of exercise and recreation.
Well, and so that's where the multiple things are allowed. So they sent a survey to their bike share customers. So he's like, so really, I have an issue with the survey, not even just.
And like work-related meaning versus right. I don't feel like that's.
Is it differentiable enough? So can we take action on this? Or do we realize that we can't take action on this? I don't know. So anyway, so we got some bike sharing data. So if you guys wanted to go back and look at where the data came from, and this semester, the reason I brought this up is because my question for you as we go forward today. So we're going to get into SAS or SPSS modeler first. Do you want to play with your churn data sets, or do you want to play with the capital bike churn data set? How many say churn? I want to play with churn. How many say not even paying attention?
What's the question?
We're going to get into software. How many people want to play with churn data sets?
Okay.
How many people want to play with capital bike share data set?
I vote churn.
Sorry. That was kind of a. All right, so churn it is. You guys wanted to steal what's going on there. All right, so IBM SPSS Modeler, not cool enough to make the top 9 tabs right here. So you got to scroll down, and it's IBM SPSS Modeler 18.1. IBM SPSS Modeler 18.1. So we did SAS Enterprise Miner last time. We're going to do IBM SPSS Modeler. I'm only going to spend about 10 minutes on this because your goal is to explore it this week. Okay, so I just want to make sure you get in, get the big picture, and then we're going to move on to the next. So we're waiting patiently. I'm waiting patiently. So SPSS is a little more, I think, I don't want to say user-friendly. It's a little more, it's developed from the social science. It has been improving and improving. It now lets you integrate some Python and some text analytics. Let's just do a little bit more. Do you guys see anything on your screen? Awesome. Just waiting over here.
I think it's asking me what would I like to do.
What would you like to do? You can probably cancel out of that screen. There we go.
That's the one.
So what do I want to do? You can not show this dialog box ever again if you want to. Or once you start doing more stuff in it, then sometimes it'll kind of pop up. So I'm going to just cancel out of this for now. So the first thing we've got to do is we have to be able to get some data in. So if it's not still there from last time, you need to have your churn dirty data set somewhere where you can access it. You should all be able to access it at this point if you did assignment 1. So the first thing we're going to do is we're going to bring in and we're going to start out with just an Excel sheet. So I'm going to start with my sources. So there's really no rhyme or reason to these down here at the bottom, these tabs. And inside, there's really no rhyme or reason as well. It's not alphabetical, it's not anything, it's just the order that they made them. We do have the crisp DM process over here, where you can actually, the more you start doing things, you can store them in folders. I never do, but it's here. So what we're going to do is we're going to take the Excel, so down here at the bottom, kind of in the middle, it's going to read data from Excel files, and we're going to drag this node up into our stream. It's called a diagram in SAS EM. It's called a stream in SPSS. We don't have kind of that left panel, right? In SAS EM, we have that left panel where everything happened. Here, we're going to do a bunch of right clicks. Right? So we're going to right click on the Excel, and we're going to edit. And here we've got more tabs. So our file type is going to be a .xlsx. Life is good. You want to save all of our data as .xlsx if at all possible. You do have the option to do a .xls, but SPSS gets really mad in this version. So it'll let you do it, but it gripes at you. So we just want to go ahead and save it here. We're going to import a file. So we're going to go to the little ellipses on the right-hand side. I stored mine on my desktop. I'm going to pick the churn dirty data set. So you go navigate to find yours. There is a churn clean. And for assignment 3, you can use the churn clean if you want to. But for assignment 2, it's churn dirty. Will I know? It's like, yes, because you won't be able to clean it. So SPSS, unlike SAS, will let you choose by index. So if there was multiple Excel tabs, you could actually choose the Excel tab. In SAS EM, that's not an option. So something to kind of keep in your mind. Making sure our range starts on the first non-blank row, our first row has column names, just regular things that you would check when you're importing files. We can next go over to the filter tab. And so if there's any data that we know we never want to see again, like I do not care about the ID ever. So I'm just going to get rid of the ID. Maybe I care about the account link, you never know. The phone number, though, I definitely don't care about the phone number, right? We decided the phone number was unique for all 3,333 rows that we have, so I'm just going to get rid of phone number. So anything you want to get rid of, you can do right here. You're never going to see it again. Then we can go over to the types, to the right. And so now SPSS has done its best job to try to understand what type of measurement the different variables are. So state's a categorical variable, account length is a continuous variable. What about area code? It's really categorical, right? So SPSS sees numbers and says it's continuous, but we know that really we have 3 categories. So we can click on this and change it to categorical. If you wanted to get more specific, you could change it to nominal, right? Because there's no real order. I mean, there is, but there isn't really an order to area codes. If we just had 2, we could use a flag, right? So a flag in SPSS, it's binary in SAS-EM. So the verbiage changes a little bit, but the ideas are always there. So I'm going to do a categorical variable here. Let's say I'm interested in churn. Yes?
I'm going to kind of throw you off topic.
That's okay.
But, so before phones became mobile,
yes,
area codes were kind of limited to a geographic area.
Yes.
So at that time, does order matter in that case, in the sense that it's related, it's tied to a specific thing, as in like a parameter area?
It's tied to it, but I wouldn't say, because like, is 405 better than 501?
Well, in rank order, no.
Right.
I mean, so ordinal is based on rank.
So ordinal is based on rank.
Based on some sort of rankings.
Yes.
Okay. Okay, that's just what I wanted.
Yeah.
So
yes,
it's not necessarily that it's tied to.
So it's meaningful.
Yeah.
Yes.
Okay.
But it's not ordered.
Okay.
Yeah. That's a good question.
Okay.
A good example would be like job titles. How you have like a level 1, level 2.
And so there, order would matter.
Yeah, that would be ordinal.
Yeah. All right. So area code is categorical. We like churn, so I'm going to go over here and kind of scroll down. Churn's at the very bottom. So in SAS, everything was alphabetized. In SPSS, it's in the order that's in your data set. So I'm going to find churn, it's categorical. And I'm going to change it from an input variable to a target variable. And you can do all sorts of fun things. We're going to stick really, like I said, really specific right now.
What does that do?
So the target variable, as we're going to go through our models, we'll see with our descriptive statistics that it's just going to do everything in terms of churn. And then for our model, like when we do a multiple regression, or in this case it would be a logistic regression, it's saying this is the thing that I'm using as my target variable. This is my dependent variable. Everything else is an input, it's a predictor, it's an independent variable. This is the one that we're trying to predict. So the other thing that we definitely want to make sure we do before we leave this screen is this fun little green arrow that says read values. You want to read the values in. If you get an error that has something to do, go ahead and click OK. If you get an error, something about my data is not working, one of the first places I'm going to send you back to is, did you click the read values? So right here, or SPSS has read the values, giving you kind of some ranges, some examples. This piece isn't as important. What's important is that it has now taken the data really out of the Excel file, and now it's really into SPSS really used. So we're going to click OK, and now we have data in our Excel file. So you're going to play around with the graphs. You've got all sorts of fun graphs that you can explore for assignment 2. For me, really quickly, what I'm going to do is I'm going to go into the field ops. And there's all sorts of fun stuff, and like I said, we'll explore these as we go throughout the semester. We have an auto data prep that kind of helps us standardize our data. We can filter, so if you didn't filter at the beginning, or if you didn't change your data type at the beginning, we have extra nodes. You can do this along the way. There's all sorts of fun stuff. The one I'm going to use right now is the partition node. Right? We talked about partitioning, so the idea of cross-validation. right? So cross-validation, our idea was we have our big data set, and we're going to divide it into a training data set, a validation data set, a testing data set. Most of the time for our class, we're just going to do a training data set and a validation data set. And so the idea of the cross-validation is I've done this with my training, and now I'm going to validate it on another data set. That's the big picture behind cross-validation. So for here, for our partition, I've got to get my data to connect to my partition. So two ways to do this. You can either right-click and click Connect, and then just connect to the partition, or you can select Excel, click F2, and then connect to the partition. Anytime you want to do anything, you can either right-click and edit, or you can double-click. In this case, I'm going to double-click. You're going to get the same place. Here you'll notice that SPSS does a training, a testing, and then a validation. Doesn't matter. The concept stays the same. One data set to do the training, another data set or two, or subset of the data set or two, to check it, to validate on it. So whether you use the word validate or test, it doesn't matter. So for me, I'm going to do a 60. And now it says the partition size is greater than 100%. That's just crazy. So now we got to take it down to 40. I love nobody typed it in. I just want to see what happens. Right? So you can create, there's a random number seed that you can generate. So you guys can all, like, if you change that seed, and there's no way you're going to get the same answer as your buddy. And so that's kind of what you have. It has an annotation field here. So when you really get into more complex models, you can actually write notes right inside the node, which is actually kind of cool. I never do it, but it's kind of cool. So now we're just going to apply this. So now we've got a 60%, 40%. We've done our, click OK. And really quickly, I'm going to do, let's see, I'm doing churn. Let's do a neural network, just because I know it'll work. So I'm going to go to modeling. And again, here, there's all sorts of things. Okay? And we'll learn a lot of these as we go along. The first one I'm going to do, I'm just going to put in another node. It's a neural net node. I'm going to connect these. So here I'm going to right click and click connect. Okay, so these are our nodes. And I'm not going to do anything to this. Okay, I'm just leaving it default. Up here at the top, there's a green arrow that says run the current stream. You can also select the last piece and say run. There's lots of different ways to do this. There's no way. So I'm going to run my node. It's going to do its thing. It says node churn is running. It's executing. It actually gives you nice little timestamps. And whereas SPS or SAS gave you a clear click here for the results, SPSS gives you a little nugget, is what they call it. And your models, your outputs are over here. And with your nugget, you can double click on it and kind of see some of the results. So here's a picture of what your neural network looks like. Doesn't that look like fun? That's going to be like week 11 or 12 maybe? We'll talk about neural networks. That'll show us which variables are most important in trying to predict churn. Kind of cool. So we'll get into all of this stuff. One of the bad things about SPSS, that's kind of really all it gives you. It doesn't give you a lot of information. So occasionally, coming from this node or coming from this nugget, I'll go to output, and I'll actually add more things onto the output and say, okay, I want to analyze my output. So I took the third one over. I took the analysis. I want to magnifying glass. I want to look at this deeper. I'm going to click on churn. This time I'm going to hit F2, and the little connector thing pops up. Now I'm going to run this analysis node, so you can either do the green arrow up at the top, or right-click and run. Control-E. So it seems weird that Control-E means run. So here we're finding out that our training and our testing are getting very similar percentages, so we don't have that overfitting thing happening. And we have a model that's predicting churn correctly 85% of the time. It's kind of cool. We don't know what it is. We'll learn about that later. But we have a model that's going to predict if the customer's going to churn 85% of the time. So this is kind of SPSS. You'll get to play with it more this week. Questions, comments? Yes.
First question is, how do we know that how optimized is this model, like in terms of accuracy?
We'll talk about it next week when we do some models.
Okay. Second question is, okay, right now we are building the model, but supposing we deploy it in production. So will there be a stream of data that keeps coming in, and then?
It can be. So like it could be a model that actually has like every day it brings in something different. Depending on what you're doing, that may or may not make sense. It's possible that you could have a model that you update every quarter. Right? So here we're going to have this model's predicting churn at 85%. We're going to implement our changes, collect data for, depending on the size of your company, a day, a week, a month, a quarter, and then we'll revisit our model. Some people will make pricing models or churn models that stay for years, which seems not real smart. But, so it's not necessarily an everyday type of thing. It could be, but it doesn't have to.
And then as part of the optimization exercise, we'll also be comparing the models
Oh,
to
yeah.
see what did we do to.
So within each lesson, you'll do multiple models, and then across lessons, we'll do similar data sets, and you'll compare models with different techniques. Yeah, we'll do a lot of comparison. And then, so starting next week, you'll actually start reading about what metrics are best for comparing linear or comparing estimation techniques, and then what metrics are best for comparing classification techniques, and we'll talk all about it. So this week, it's all just about, and this is where my students have problems on Saturday. They want to know all the things right now. Okay. We got 16 weeks. This is a 16-week-long journey, so we got 15 weeks left. It's a 15-week-long journey. This week, I just need you to get familiar with the software. Okay? Have as much fun as you want. But this is where I was telling you that this is a class, not a this class. And when you start to do this, you make the class harder than it has to be. Now you can learn as much as you want to. Have fun, please do. But, all right, so where SAS was on our environment and you didn't really save anything, here you have a nice little save floppy disk that no one ever uses. So you're going to have to file and save as. You save your stream as whatever you want to save it as. So here I have a face-to-face stream one. Yeah. Wednesday lesson 1, whatever. But you actually have to save the stream in SPSS model. Yes.
What is the difference between saving stream and saving the project?
How is saving the project?
Yeah, it says attach it as a project.
It's inside project.
Yeah, I'm going to say the project's going to be your multiple streams. Like, so when you're actually saving, like, so here, this Crispy M thing, this is like your unsaved project. So if you're doing multiple streams and saving them over here, then you would save a project. For us, for most of what you're going to be able to do, you'll just be able to save a stream because it'll all fit on the one page. And saving either one would be fine. You can save the project that just has one string in it. Alright, so once we save it, we can exit out. Life is good. Alright. Our next option is SAS Viya. We're going to be using SAS Viya. I've shown you the other two. Our other two we're very established. We have tutorials for them. SAS Viya is new. We're going to be playing with it. We're going to be experimenting with it. Apparently you guys are test dummies for all of your classes, the way I'm understanding it. ERP2, you guys are trying. You guys, not a lot of you are in ERP2 though. So never mind. So ERP2, you guys are test dummies, and here, you're not dummies. You're really smart, which is why I feel like we can do this with you. So we've got SAS Viya. There is a link on your VMware. So if you're in VMware, you can click SAS VIA, and it takes you to say yes, say open. We can't verify who created this. Michael Gibbs created it. It's fine. Click open. Okay. But when you click open, you'll notice what's happening is we just popped up a new web browser. Okay? So, the cool thing about this is VMware, I don't need VMware. Right? So if I get out of VMware, and I'm just on my regular desktop, go Google. I'm on my regular desktop. If I type wcob via.uark.edu, I'm going to the same place. So the cool thing about VIA is you don't have to use our VMware. Your user ID is just like logging into your email. Does everyone who wants to follow along at this point? All right. And when you open it up, you guys probably won't have anything here, and that's totally fine. You'll start to get, as you start to make reports, more things will start to populate within right here. So this is your basic SAS drive organization, kind of how things work. One of the great things about SAS VIA is that it's going to allow for easier collaboration. There's some things that we have that are working perfectly. There's some things we're still working on. And as we run into problems, we'll fix them. But this is a really great tool, I think, for kind of bridging the gap on ease of use and fun visualization. Okay. So the first thing we'll do once we get here is we need to get data in, just like we've done in our other options. So in the top right, you see new. The other thing that I really like about this one is it's on the web browser, so I can make things bigger, which I can't do in any other software. So we're going to click new, and you would think you would want to create new data, but we have no new data option. So we're going to create a new report. And as we create a new report, I was working on stuff before. You shouldn't see this. You may see something that pops up really quickly that's like, here's some options for either getting some new data, and then it goes away really quickly. So if you're really fast, you can click on it to get new data. But if not, no worries. Over here in the top left-hand corner, you'll see the 3 stacks that'll say data. So go ahead and click on that. Okay. Now here is the lovely fun part. The semester's already progressed, okay? And what you'll start to see is there's a churn clean, and you'll see here's churn assigned to, clean, dirty, clean, churn dirty with somebody's name. There's all sorts of churn dirty for. Right. What's happening here is this is the public file, which means if you save things here, everyone can see them. So if you want everybody to see the work that you did, by all means, public file. I'm going to recommend not. Okay? So we're going to go over here to import. And then we're going to go from a local file. So mine's on my desktop. Oh, it's not on my desktop. Let's see if it's in my box. It's not there either. Look at that, you guys don't even need me. Okay. So I'm gonna go into my, I'm gonna go do it this way so that way I can actually. So one moment please, let me catch up with you guys. Alright, so hopefully by now some of you have already, you're like, oh yeah, I've got it imported, and you just realize that, oh, I imported to the public file. So that's the part I want to make sure. So we're going to click on a new report. And you'll notice up here in the top, it says you're in ISYS Visual Analytics. So Avaya actually has several different platforms that we're going to be able to access from. So we're going to start out in ISYS Visual Analytics. So you guys are bringing in your data, you're importing your data, you went to the local file, you found where you kept it. There's my churn dirty data set. So you have your target table name, so this is just whatever you want to name it, which is fine. And your target destination is your big thing. This is the piece you want to change. So you'll click the little file box. And the place you want to keep it, which should be at the very top, you have a CAS user, and it should have your username. And this is where you want to keep your stuff. So go ahead and select that. If you're trying to replace a file, you can do that without any problems. If you want to specify a worksheet to import, you can. So if you have multiple tabs on your Excel worksheet, you can actually pick the right one. I don't think there's anything really in the advanced we need to worry about. And then you're just going to import the item. So it is exactly what you would think. It is fairly straightforward. The big thing you want to make sure is just to make sure that you change this to your user library, because the default is a public library. So you should hit import item. Mine already exists, so it gives me a little red X. So I either have to go back and replace the file. Okay. You guys should hopefully have a little green that says table successfully completed. All right. And then once we do this, now when you look at available, you should be able to scroll through everybody else's and find dot whatever your username is. That should be something that's available to you. So I'll go in and I'll start after assignments are finished. I cleaned it up once and then students were like, you cleaned up my data set that I was using for my assignment. That was kind of mean of me. So when everybody gets this finished, I'll clean it up again. But so pick your data set and then let's see what happens. So from the available, pick your churn dirty data set.
How did you get to this one? The open data.
So you click OK, you import,
Right.
and then what screen did it take you back to? It took you back to the original. Right? So if you went back to the original, then you're going to click on the data one more time.
Oh, it's already, okay.
Yeah, so it should already be open if you just
Yeah.
imported it.
Okay.
But if not, if you come back, and so this is like, once you already import it, if you need to come back and get it again, or if I tell you, hey, I've already stored it in the public file, and you're just picking it out, anytime you go to data, you're opening your source data, it's one of your available source data, find the data set you want, click on it.
It's smaller now.
How large is it? So now, just like we have with our other variables, it says here's the name of your variable, here's the type. So double is going to be a continuous variable, the variable, the character. Right, so your character variable, you got the link, how it's formatted. I mean, so this is just kind of some basic information. We've got 22 columns, we got 3,000 rows, what we're expecting. You can go over to the right and click the sample data. You can actually kind of get a little snapshot of what the data look like. This is the first 100 rows, or 100 sample rows. You can go to the right again and you can click profile. I think something should pop up that says like run profile. It pops up and say run profile, go ahead and do that. Once you've run the profile, then you don't have to do it again. So like mine just popped up because I did this in my Saturday class, and so I've already run my profile. And this is nice. because it kind of tells you a little bit about your data.
Sorry.
Go for it.
I'm having trouble getting to that.
So did you get,
So like when I exit out, then it like shows up all the, then when I click on data again, it like shows all the
options.
well, it shows all the fields, so like it already has like churn data. Or maybe, yeah. Oh, okay.
You get it?
No. Okay.
Excellent. Right, so what we kind of have around here is like, here's our unique variables. Remember, notice at the ID, we have 100% unique variables. If we scroll down to phone, 100% unique variables. So yes, does everybody have a unique phone number? We just answered that question. Right? Do we have missing data? Really, the only missing data that we have is just we have one churn variable that was missing. We've got means, median modes, standard deviations. Let's scroll to the right and get a little bit more. Mins, max, the data types. We have if they're primary keys or not. You guys all know about those now. So the non-null values, you'll notice that it's right except for this one, because there's one missing value. Okay, so it's just kind of a profile of the data. It's a quick summary of what's happening in my data set. Okay, so I'm going to click OK. So you can get some descriptive statistics there, but not really all that helpful necessarily. One of the things that we're in, like I said, we're in this visual analytics. So this has kind of a little bit of a Tableau feel, okay, to equate it to a software we've used before. So here we have categories and we have measures, right? So categories for our categories for our categorical variables, measures for our continuous variables. Area code, right? We said that was really categorical. So if I click on the double arrows next to area code, name is area code, I like that, but the classification is not a measure, I want it to be a category. So I change it to category, and then it pops up here and says, okay, well you have 3 area codes. All right, so now you want to go through your data and make sure that the software is thinking about the data the way that you're thinking about the data so that you can use it appropriately. You can get rid of variables if you want to. Here you have some aggregated measures. You can create measures. We have some tutorials on how to create measures. But a lot of this stuff is kind of like what you would think. You can create a new data item, where you have a calculated item, or if you want to turn something into a geography item, you can partition data. We talked about needing a partition. You can partition the data here. So below the data, we have the Objects tab. The Objects tab lets us do all the fun things. So we can do crosstabs for us to kind of think pivots. We can do all sorts of different types of graphs that you guys were having fun talking about earlier with our visualizations. We can do control. So this is actually going to be an interactive web page. We'll actually be able to create stories with this. We can do analytics. We can do some path analysis or different network analysis. We won't use these a whole lot. We have containers just for making like places where people can add information to then do something. We can add web content to what we're doing. This is going to be pretty cool for us. Okay. The SAS visual statistics, this is really where our home base is going to be. We're going to be doing cluster analysis, decision trees. Here's our linear regression, our logistic regression. We'll be able to compare different models when we make all of these. We'll do some data mining and machine learning. We'll do some Bayesian networks. We'll do some forests. We'll do neural network. We may talk about, we'll do gradient boosting. We may talk about a support vector machine. I haven't decided yet. Okay, so this is where kind of everything's going to be right here. So for now, I'm just going to do a quick little graph. What kind of graph do we want to do?
Butterfly chart.
Butterfly. Why not? Got nothing. So what did I do? All I did was click it and dragged it into the middle. I said, okay, butterfly chart. Okay, it says the required roles have not been assigned. Well, what required roles do we have? Over here on the right, okay, we have options. The options makes things pretty. We can make things pretty. Here we're going to have roles, because it says the required roles haven't been assigned. Okay, well, it looks like we need a category. So we're just going to click Add. What category are we interested in? State. Let's go big. I was going to go churn. State. Oh, we still don't have the required category. We need some type of measure. So what are we going to measure state on? So it's got to be a measure, so it has to be a continuous variable. Day charge. I heard day charge. I don't really care. We're just going to do something. Oh, look, we need, because it's a butterfly chart, it's going on both sides. What other thing do we want to do?
Night charge.
Night charge, evening charge. Ah.
Boom.
Oh.
It's beautiful.
Look at that. By each state, in alphabetical order. Right, we can hover, I'm not really sure what that guy is. Right, we can hover over Mississippi. Here's the day charge and the evening charge. Down here on WN.
Yeah.
Okay, so something's happening there. Sorry, so you said it's kind of a detection there. You can start to kind of see what's happening up here in California, where all the area codes are. Who knew? Okay. So you can kind of see what's. So you're going to be able to have any of these visualizations. You're just going to kind of follow the directions on the screen. Okay, it's fairly intuitive playing with this. So you guys are going to get to play with this. Do you have any last minute questions, comments about the software itself? All right, so we've been able to get into all three of our softwares. Yes. Yes, that's the best part. So when you're finished, this isn't on our SAS server, so you are going to have to save. So same idea, right? You've got your save little button right here. I think that's actually the best way to go about it. And then it's going to pop up where you're going to save it as. So you have a SAS folder that you're going to be able to save it in. It's your SAS folder. You could save it in public. And so this will start to be, we'll be able to create group folders for each of us for your group project. And then everybody will be able to share nice and neat and see what you did. And you can add a page and keep things together, yet keep things separate and really tell your story well, as opposed to the craziness with Sassy G of it's in your phone.
Hopefully you gave permission to go into my folder.
Alright, so we'll make kind of some of that stuff happen. So you got your report name, you got a type. Right now we're just doing a report. So there you go. And then you'll be able to exit out. The one thing do make sure to do, because this is on our web browser, make sure to go ahead and sign out, just to make our system run better. I'm not going to worry about saving my changes right now. And you've signed out. So visualization, your game is to play with the visualizations and to get to know the software. That's really the big goal, is to get to know the software this week. Okay? It is going to take a little bit of time. You are going to have to play with it. But a lot of it's intuitive. A lot of it hopefully has steps in it. If you have questions, use your discussion board, send me emails, whatever works the best. Stop by my office. For the next, we've got 15 minutes left of class. It's not going to take us 15 minutes, I don't think. We are going to have our project. Did I challenge you guys to be epic last time?
Yes.
I'm still going to challenge you to be epic. So project prep 1 that we're going to have, it looks like it's due, I don't remember when. Not Thursday. I marked this out last time.
Yeah. You're all ready.
You're like, yeah, no.
13th of February.
Look at you, February 13th. So overall, the end of it, February 13th. So your goal from now is to, by the end of the day, before we leave, we'll have our team set up. Okay. It's going to be a 3 to 7 minute presentation, and the whole big idea is finding your data set, coming up with some initial business questions, and coming up with what you think may happen, starting with a hypothesis. Okay. You're going to have one presentation, you're going to have a one-page executive summary, and I'm going to see your data. I've already asked the question. If anybody wants to use their old data. Question though, for those of you who did the Walton Arts Center. If you had updated information, but not concession data, would you then be interested in using it? We did just get updated data from the Walmart AMP up through 2017. 2017, it's the 2017-2018 season. So if you're interested, we do have new data to add to it, but we still don't have concession data. They are adding a field so that you can connect the location to the attendance. So that's one thing that you guys asked for. They are adding that. So if you want that, that is new and improved. If you want more prior data, I'll get you more prior data. Other than that, your goal is just to find whatever data set you want to. Right. Have fun. I don't care what it looks like as long as it's big enough. Big enough. Right. We're going to be doing data mining. You want enough. So you want big enough data, and then you want enough variables. That's going to be kind of your big thing, right? You don't want to find a data set that only has 10 variables. You want to look for something a little bit more substantial. If you need help with it, I'm here to help. Other than that, do you have any questions?
I'm in ISYS, and I just have a question on the 6 steps, right? Business understanding, blah, blah, blah. And I saved the model, and it seems like it's just, you have a big project, and these seem more like a folder representation of the...
Yeah.
But does it have any other deeper meaning?
Not that I'm aware of. No. It's just
I was able to actually drag and drop the model
streams
files,
into it.
So it's just to say that I'm at this stage. Whatever.
Yeah, it's really just as you're working on a bigger project. Here's what I did. So like, you may, instead of putting all of, like, you may do your data prep, and then put it into your data prep folder, and then export it, and so you don't have your data prep and your model in the same flow. You may have your data prep in one, and then you can go save it over here, and then have your model where you're actually trying all different models in one, so that way you don't have Alright, so my goal is, in the next 10 minutes, come up with your groups. 3 to 4 people. If you need help, don't leave before you have a group, before everybody has a group, so we can make sure we're good. I'm just going to clean off that board. When you're happy with who you have, go write your name down, and then we'll see how many teams we wind up with.
Can we keep the photos?
Huh?
Keep the photo.
I already took the photo. Yes. Yes, I already took the photo, so you're good to go there. If you want a group that's bigger than 3 or 4, you're going to go with a really good data set to make that happen.
You want to join? I feel like we're going to get this team for every class. Next semester I'll be by myself with my new friends. Well, the people who are
So if you want to be friends with people in other classes, or if you want to stay away from people you're working with in other classes.
How about you?
You free again.
I think we should
I have a quick question about there's like a ballot that has like all this. Oh, say it's like all like 7 for like people.
I don't know what it is. You buy some
Yes. Yes. So like in general, I probably wouldn't, but in that case, right? Like, yeah. Okay. Oh, writing in, like I didn't. Okay.
Okay, I'm with you. So who's the third one?
I'll be on a team with Kirsty, so you guys.
My goal, so here's my optimal thing. I want six groups. 6 or less groups. We've got 20 people. So, I mean, you can have 4 groups of 6.
There would have to be
That's just going to be a little crazy logistics-wise,
at least 2 groups.
right? So 3, 4, I'm okay if you can hit a group of 5. It's fine with me, but you're just going to have a big enough data set to handle 5 business questions. So, at least 3, no more than 5. So if you guys want 5, that's fine. You're just going to have to find a data set that will handle 5 data miners.
I mean, not
I managed to find out, and then she starts telling everyone, "Oh, ask Sam where she's doing." I know what that is.
No, I figured out one time.
Exactly.
No, this is the.
That's nice. But isn't the data, like, that's usually just. You can download it.
Well, the only data on it could so I don't know what's really. Yeah.
So, like, hey, I found this, and see what you're saying. Then we just pick it up, like, these links, ones we found.
Now, the thing to think about is, can you do a data mining question?
They don't even really
Data mining question.
share like how the data
Data mining question. When you find your data set, data mining question.
So that means like predictive. Fine.
Right, so you're going to have to predict.
Yeah.
Not you'll do your
Is there a box on it?
Let's see.
You're not going to want to use sentiment analysis for your project, so we'll do text mining as opposed to sentiment analysis, but you're not going to learn that until week 13. So generally for the next step here, I want you to like supervise tasks, and then, oh, sorry, one other caveat, linear regression is not an okay model to use. Like you can use it as one of your models, but that can't be your primary thing. Throwing that out there. You're gonna learn linear regression, you're gonna learn Hayner's neighbor, you're gonna learn decision trees, you're gonna learn neural networks. You'll have 6 different estimation tasks that you can do. You can do linear regression as one of them, but it can't be your only thing. So you're gonna need 5 data mining questions. If you do a group of 5, 5 data mining.
I mean, depending on the size.
So 3 people, then 3 data mining questions.
What question? What sort of model data?
You answer the same question. So, like, ideally, what will happen is it's supposed to predict churn. Okay. Well, so churn is a categorical variable. So I'm going to go into my supervised categorical, and I'm going to say, okay, I can do logistic regression. I can do it's called a Hayner's neighbor. I could try a decision tree. I could try a neural network. And so you're going to have 4 or more different models that you can try. You're going to figure out which model gives you the best prediction. You'll have a regression node, you'll have a neural network node, you'll put them all together and then compare them at the end and say, so kind of like the very first day, you pick like a Hayner's neighbor node, a neural network node, put a model comparison at the end and say, oh look, both of these models predict at 85%. So there wasn't a big difference, so I picked the one that I could explain it better. Generally, you'll tweak enough of the models, one model's going to be better. And that's one question.
So in our,
So that's why you're only doing 5 questions instead of like last semester you had like 5 descriptive questions, hypothesis questions. This is just it's going to be 5
Again, that
questions.
does come
Start
down
with the
to how
beginning.
much available.
Why do you start with the beginning and you just learn more models and the model works?
Which, I mean,
Then you try. And later, if model doesn't work,
possibly.
then next time.
and the final question.
Oh, you worked on it. That's
Something like predict the turn.
But at there.
X.
Oh, yeah.
So our data set.
When you work on it.
I don't think we've done something
Yeah, I don't know.
but it's like separate,
Oh yeah, that's totally fine. Yeah. So if you find out that a decision tree is the best model for every question that you ask,
I don't think there's
that's fine. The point will be, so I want to predict this, and this. And you may have decision tree work for all of them. You may have decision tree work for this one, and neural network
I
works
do kind of
for
like
this
the idea
one.
of trying to go.
That's the bad thing about starting it right now, is that you don't know what's coming.
Yeah, I think.
So right now it's just find a data set that you can be able to predict 5 things.
Yeah, looking into the business side of that.
It can be anything you want. It can be health, it can be sports, it can be Fitbit data. You can get a whole Fitbit data, you just go for it. It can be anything you want. So if you want to make a business data, you can. If you want it to be something that you guys will actually have fun, you're going to spend 15 weeks with it. You're going to want to do a little bit of background research on I've had people, like I said, fantasy football, terrorist information, like just different, like trying to terrorist stuff. You can do crime stuff, any kind of IoT stuff that's out there these days. You have the telecom data set that I have that has got 100 variables, right? So it's great, but really when it starts getting down to predicting things, you're like, well, I could predict churn, or I could predict the number of customer service calls. They have certain features, and I mean, it is an academic exercise. So you may ask to less than optimal business questions.
Eric, and I
Right?
wonder
You're trying to get
how much
used,
more
even with
difficult
100 variables,
look into
you're like,
something
I've got a whole bunch of things to try to predict churn, but I may not have that work. Yeah, you may want to try and predict how long your customers will be. Right, so you can predict
Is there data on the very
And also, like,
trying to
like
predict
the wall.
how many people
That was nice. So,
Oh, absolutely. Yeah, if you want to combine data sets with different things, you want to do that. In fact, yeah, your goal is going to have to be to combine multiple data sets. So if you get a head start on it here,
how many of those students?
I think something like that.
I think it will, because I think this knocks out a couple of
It's not 5.
Yeah, it's definitely not 5. So, but you may be able to split 2 and 3 options. And you may want to think about that when you make it.
I mean, it's fine.
You guys, alright, picked up the stand guy. Picked up the stand guy.
But we don't have to.
Okay, depending on like a couple like data mining questions. You have to be able to stand it.
Alright, so it is 11:35, so if you have your groups, write them down. We don't have the room as long as we did last time. There is a class that comes in 15 minutes later. So
we need a use case. Which we can find things. We should have the data.
Yeah, we say the search
So do you wanna?
It would be a new data set.
Yeah, that's something I'm gonna
What are you doing?
Unless we find something
Unless we find something.
Right. We're thinking, like, we like an idea of doing soccer.
Isn't that like?
Is that what you want to do?
Yes.
Every time I open it, some of it,
That's how the register is like $1,000.
Yeah.
I have to have them sign this and say,
So make sure your name's on the board. Ready?
but if you get $1,000, you have $900. That's exactly what I
You're not gonna
Well, you've got a year to come up with a house.
I got an internship over the summer. And we're
Top internship.
just,
Yeah.
I mean, like a wedding.
Oh, you'll get one of We'll give you money. You're good. Yeah. Like,
Straight to my
like
CPA.
Ryan got it.
That's great. I love that.
Yeah.
Yes, please. Give me money.
Yeah. If people are lazy and they don't want to go buy yours, that's so true. Yep.
I'll take it.
Alright, see you guys.
See ya.
Bye.
Oh my gosh.
Yep, my turn. It's gone after 10.